So let's look at the chi-square statistic. This is a formula. This formula might look odd a bit until we see an illustration. So these are the notation, but I won't waste so much of time on this because an illustration on the next slide would solve all of these complicated notations. This E can be calculated using this formula. Then to calculate our degree of freedom is R, which is the number of rows, minus 1, then times C, which is the number of columns, minus 1. The degree of freedom, which is R minus 1 times C minus 1, is used to check the critical value on the chi table at the specified or the appropriate level of significance. So when it comes to the null hypothesis, the idea here is that the classification you are dealing with, or let's say the two classifications you are dealing with, from what we talked about on the previous slide, we were dealing with two classification or categories, geography and investment type. So the null is that geography and investment type are independent of one another. That is, they are not related to one another. Then the alternative is that geography and investment type are related to one another. That is, they are not independent of one another. So once you are done with calculating your chi-square statistic, then you compare it to your chi-square critical. So if chi-square statistic is greater than chi-square critical, then you reject your null. If chi-square statistics is less than chi-square critical, then you fail to reject your null. Still moving on, standardized residual is computed as follows. We agreed some slides back that chi-square statistic is the observed minus the expected squared all over the expected. But since we're interested in the standardized residual, then we will find the square root. So finding the square root will imply that we will have something of this nature. Observed minus expected squared all over the square root of expected. So I can take this out, and what I would have is this. So standardized residual is this. It is also very important to note that as far as this chi-square is concerned, it is a one-sided rejection region. So regardless of whatsoever your null or your alternative is, you would always use a one-sided critical value. So let's look at an illustration. This illustration is not from the curriculum, but this will help us understand everything about chi-square, the chi-square statistic, and the chi-square critical. So let's get started with the observed variable. Let's imagine this is one classification and this is another classification. So we were given this on the exam day. The first thing we need to do is to add them across board. If you add the whole of these together, you will have 10. If you add the whole of these together, that's 22. If you add the whole of these together, that is 8. If you add the whole of this together, that's 20. If you add the whole of this together, that's 8. If you add the whole of this together, that is 12. So adding all of these together is 40, or we could say adding all of these together should be 40. So what we have here is basically the total of each of the cell. Now let's move on. We have the observed value. We now need the expected value. So to compute the expected value for this, the expected value for this would be what we have here against what we have here. That's 10 times 20 all over the total amount, which is 40. And you should get 5. For this, the total here against the total here, which is 10 times 8 all over the total here, and that is 40. Then I expect you to get 2. You can keep on going on, but let's do one more. Let's say this. So that's 22 times 12 all over this, which is 40. So if you solve for it, I expect you to get 6.6. So we have our observed value, which is the whole of this, and we have our expected values, which is the whole of this. So the next thing is now to calculate our chi-square statistics. To calculate it, this was the formula I showed some slides back. We have our observed. This is our observed. Or you could go with this, anyone you want to go with. This and this are the same. Then we also have our expected. So observed, which is 4, minus the expected, which is 5, all squared, all over the expected. This still remains the expected. That's this. That's 5. So if you solve for that, I expect you to get 0.20. Let's do one more. Let's imagine we are picking this. We start with the observed, which is 2, minus the expected, which is 4.4, all squared from what we have here, all over the expected. The expected is 4.4. What do we have? What we have, or what I expect us to get, is 1.3. So these are the chi-square for each individual cells. But what we need is the summation of all of the chi-squares. If you sum all of it together, then I expect you to get 10.85. So this will now be compared to our T critical. But before you can get your T critical, you need your degree of freedom. Or before we move on, let's imagine that what we have here is strategies. And what we have here, let's imagine, is fund managers. So we can form our null. Our null would be that the fund managers are not related to the strategies. Then also for the alternative, the fund managers are related to the strategies. Please, if the fund manager are not related to the strategies, what we are saying is the fund managers are independent of the strategies. Here, the fund managers are not independent of the strategies. So let's go ahead to calculate our degree of freedom. As far as the rows are concerned, I know some candidates struggle with rows. Rows is this, then column is this. So this is one column, this is another column, this is another column. So we have 3 columns, Then for rows, we have 3 rows. So our degree of freedom will be 3 minus 1 times 3 minus 1. That means we have 4. So let's imagine our level of significance is at 5%. So we are checking 4 under 5%. This is 4 under 5%. So what we have is 9.488. So our calculated, which is this, will be compared to 9.488. Since our calculated is greater than the critical, then what do? We would reject our null. So what's our null? This is our null. So we would fail to reject our alternative.